Assalamu alaikum everybody, and welcome to Practical Numerical Methods for Scientists and Engineers. Today we'll continue our module 3 of roots of single equation, and our lesson today will be on bisection methods. So bisection method is, as you know, is a type of bracketing method. So if you have, for example, we can say okay, let's try this one. If you have x and y, and this is x and this is y, or f of x, let's say f of x, okay, and you have equation, okay, this let's take this color, okay, and you have this function, okay. Now you have upper, we said you should have two guesses bracketing the function, okay. So let's take another color, let's take this is red, okay. So now suppose that we have the upper and lower guess, okay. So this is upper and lower guess, okay. Now the idea of bisection method, he will consider the if, okay, this one will give negative function, and this one will give positive function, this positive and this one negative, okay. So if you multiply both f of x and f of x, upper and lower, and give negative, then these two guesses bracketing the root, and they are correct guesses. If both of them gives positive results, so if you multiply this one times this one and it gives positive, okay, then that's mean both of them are negative or both of them are positive. So it's important to have opposite signs. So that mean f of x L times f of x upper below 0, okay. Now the idea is that if you have x lower and x upper, so you by sections you take the average of both. So the average of both, it will be exactly, for example, here, okay. I will suppose it will be here. So it's very close to the correct one, okay. Then check this one, check the new x, or we can say xr, we can check it, okay, the result. So check it, it's positive or negative, okay. If it's positive, okay, that means I can't take this one, so I can take this one. So I will consider this one xr becomes the new x upper, and x lower will stay as x lower as it is, and calculate new xr. Again, check xr, okay, positive or negative. So it gives positive. So since it gives positive, okay, since it gives or negative, okay, so you can guess. So here it gives positive, so I can take this one, so I should consider between them, okay. Here sorry, so here should give negative, okay. So if it give negative, okay, then I will take xr, here will be the lower, and I will take x, I will keep the xu will keep as it is as upper. Then from both together I can calculate new xr, and that's it. Every time I can check the signs and go upper or lower, okay. So okay, xr here equal to x lower plus x upper over 2, and then check the status, check the signs every time, okay. So we can say that if I have fx upper and fx lower, and I have fx r that calculated exactly in between of them, then we can check. So if f of x lower times f of x f of x are, if both of them are less than 0, that means times both of them give negative, then we can consider xr as the upper and xl as a lower, and then assign new xr. Okay, if f of x upper times f of x r lower, our result gives negative, then here the xr is the lower, and I can get the new xr here. Suppose that if you multiply xr times f of x upper and it gives 0, then, or even if x lower, then that means this value is 0, because you know when 0 is multiplied by anyone it gives 0, so that means it's 0. So f of x equals 0, so this is your root, so then xr is the root and then terminate. Okay, now let's apply MATLAB on this equation. The equation says f of x equal 0.95 x cube minus 5.9 x squared plus 10.9 x minus 6. Okay, and the intervals are 2.5 and 3.5. Relative error here is given as 0.01, and the maximum iteration is 50. Okay, now it's important that when you want to add equation, to insert equation in MATLAB, you have added at x between parentheses, okay, and put your equation. You can't put your equation alone, because if you put your equation alone it will give mistake and MATLAB can't identify the equation. So you should start by add x and then put the equation. Okay, now let's discuss how to create MATLAB codes or script. So of course you create new script and then you can save it as bisection or save it by any name. You can put some display message. Okay, bisection method by Ahmed. Okay, here we need some inputs. We need xl lower limit, xu the upper limit. Okay, then we need another input, it is for the equation. And so input function, we use input function and put some prompt to just to tell the user what he should put. Okay, then so we identify the equation by f, then we can after that calculate the fx for lower, okay, by f of xl, and fu, this is for upper, by f of x upper. Okay, now before going further we need to check. Suppose that I did a mistake and put two values positive, give wrong signs. Both of them are gives positive roots or negative roots, so there's no intersection, so you can't find the actual root. So we have to do check. So if x of lower times fu upper larger than 0, that means both of them are positive or both of them are negative. Okay, then display error. So error, so it's give a sound, and then initial guess should be have a different sign. So this message will be shown. Okay, you of course you can change your message if you want, and then end. Okay, now suppose that the values are correct, so let's go for iteration. Okay, now the question assigned maximum error, maximum relative error, and maximum iteration number. So here I should identify max error. You can of course you can call it anything. You can call it m1, m2, but just I'm calling it max error. And max iteration, so max error is input, okay, and max iteration also will be input. Okay, now we identified iteration as 0 because it's a start. You will start from 0. You don't have any iteration. Once you make iteration, it will be 1. And also we start x alt equals 0. Why we put them like this? Because you, when you calculate from x, for example, if you let's take here something here. Okay, for example, here you calculate x alt, and this x alt is not defined earlier, so it will give mistake and tell you this value is not there, already mentioned there. So you have to put there and give them a number. We can put them like a 1, okay, but you can't assure it is not a 1, so we consider it 0 just to be safe and correct. Okay, now while we use while true and end. Of course, if you are working with octave, it will be while end, sorry, end while. Okay, so while true, that means when all these sentence are correct. While true, then so this means it will be repeat the loop. Okay, x new equal x upper plus x lower divided by 2, and calculate the function of x new. So now we have to calculate it, x new, and we have f new. Okay, now in order to check which one I will choose for upper and which one to choose upper, so we create this part. So now we said we have f upper, f lower, and we have f new. Okay, now if f new times f lower, f new times f lower are positive, okay, then that means the f new should be the lower value. Okay, because I should go, the root should be here. We said it should be negative. Okay, so here x l equal x new. Okay, so the xl will be the x new and the fl will be f new. Else, that means the opposite way, then x upper will be x new and f upper will be the f new. End. Okay, that's it. So now calculate the error as x new minus x alt. So it starts from 0, and then when you put the when you define the x error here, okay, x error started from 0, then the new x error will be continue. So x alt over x new times 100. Okay, then you can start iteration. Now will become iteration plus 1, so it's 0 1, and then x alt become x new. Okay, then if absolute error, this to stop the software if you reach the maximum. If the absolute error less than or equal max error, okay, so this is the absolute error. Okay, this is the error we defined here. So if it matches the maximum error or less than it, okay, or the iteration larger or than max iteration, okay, max iteration was input, okay, then break and end. So this is the second part or the iteration part of bisection. Then here you can display, so just I put a line here and then space and then display iteration. Okay, display iteration number and then num to string. We said we use this to convert from variable to string or to sentence or to word, and then because we use display, so iteration, okay, and then x display x equal x new, and then find the error. Okay, so this is how we use bisection to make to code. I hope you understand it. Please let me know if you find any difficulties didn't get the how we get the code. Yeah,
that.
thank you.